Hello, this is Professor Means again, here to teach you about limiting reagents, percent yield, and theoretical yield using the means method. And this is kind of a concept that's sort of difficult to understand initially, but hopefully after seeing my little presentation, it will make doing the math a little bit more easier to understand. So first, let's start off with some definitions. We have limiting reagent, which is the reactant that makes the least amount of product. And then we'll have the theoretical yield, which is the amount of product that can be made based on the amount of the limiting reagent. So if you want to pause here, you can write down this definition and then hit play and we'll continue. So the next two terms that we'll take a look at are actual yield, which is the amount of product actually produced, and then the percent yield, which is the percent of the theoretical yield that was actually attained. And there's a formula for that, and that is the actual yield divided by the theoretical yield times 100%. And again, you can pause to write that definition out and then press play. We need to look at one other concept. This is something that you have probably already discussed in chemistry class, but just as a review, and that is we're going to work problems using molar mass. So we need to know how to calculate that. So you may remember earlier in chemistry learning how to find formula mass. So let's say we wanted to find the formula mass of carbon dioxide. So what we do is we break carbon dioxide into the two elements that make it up, carbon and oxygen. And then we take the quantity of each. So I have one carbon, and in carbon dioxide I have two oxygens. And then we multiply it by the mass number, which you would get that from a periodic table. And I have my students round the mass number to the nearest whole number. So in this case, if you look on the periodic table, carbon would have a mass of 12, and oxygen has a mass like 15.99, and so I have my students just round that to 16. So 12 times 1 is 12, and 2 times 16 is 32. We add those together, and we got 44, and our unit AMU, which stands for atomic mass unit. Well, we are going to be doing problems not with formula mass, but with molar mass. So how to calculate molar mass? Let me take a moment because I just don't know if I have the energy to explain this extremely complicated math procedure, but I will try my best. To get molar mass, you take your formula mass, that 44, and add the units grams per moles. I know that's terribly hard to do, but just bear with me. So the molar mass of carbon dioxide is 44 grams per moles. Here we have sodium chloride, which is our table salt. So we have one sodium and one chlorine. And if we look on our handy-dandy periodic table, we'll see that the mass of sodium rounded is 23 and the mass of chlorine rounded is 35. We add those together and we have 58 atomic mass units. Again, the difficult conversion now to molar mass, we are going to take that 58 and put grams per moles after it. Okay, so we have these terms, actual yield, theoretical yield, percent yield, limiting reagent. So what did all those things mean? Well, let's take a look at a food example. And so here's my food example. And that is, if I take one cracker and one piece of cheese plus one piece of chicken, and I put those all together, I've created what I call a snacker. I've created one snacker. So with one cracker, one piece of cheese, and one piece of chicken, I can make, with those ingredients, one snacker. Okay? So these would be the crackers, the cheese, the chicken would be my reactants, and then my product is a snacker. And this is actually an example of a synthesis reaction. We're taking ingredients individually and making one final product. Let's say we have this example. Let's say we have 1, 2, 3, 4, 5 crackers. And we have 1, 2, 3, 4, 5, 6, 7 pieces of cheese. And let's say we have 4 pieces of chicken. And we want to know, hey, how many snackers can we make? Well, let's bring in a live visual aid, an edible visual aid. So here I have 5 crackers, 7 pieces of cheese, and 4 pieces of chicken. So I am now going to make some snackers. I'm going to see how many snackers I can make. So here's my formula. So put a piece of cheese on each of these. And then I take my chicken. Let's see, I ran out of chicken. Looks like I was only able to produce 4 snackers. See, this one is without chicken, so that doesn't count. That's not a snacker. So given 5 crackers, 7 pieces of cheese, and 4 pieces of chicken, I can only produce 4 snackers. So my theoretical yield, which is what I'm able to produce, is 4, right? I can produce 4 snackers. So I just abbreviated to save room. So my theoretical yield is 4, my 4 crackers. So what limited me in making these crackers? Well, I have an extra cracker, I have extra cheese, but I'm out of chicken. So I was limited to the number of snackers I can make based off of my pieces of chicken. I only had 4 pieces of chicken. So my limiting reagent, what was I limited by? I was limited by my chicken. Does that make sense? If I had more chicken, I could produce more snackers, but I don't. And, so sorry. If you can hang on just a minute, I think I heard the doorbell ring. I'll be right back. Okay, I'm so sorry about that. Um, so sorry about that. It was a false alarm. It was just some little girl at the door looking for her lost rabbit. So can't help her with that. So, like I was saying, who nibbled on my snackers? Two of my crackers are ruined because something or someone nibbled on them. These are fine, these are not. Well, I can't. I'm having some people over and I was going to serve them these little 4 snackers, but I can't serve them snackers that have been nibbled on. So I can't even use these 2. So all I have are these 2 that I can serve. What happened? My actual yield now, the only crackers that I can actually serve are 2. 2 crackers, even though I made 4, 4 is my theoretical yield, these 2 are defective. So I can only serve 2. I can actually serve 2. So my actual yield is 2. I'm going to calculate my percent yield. So my actual yield was 2. I can only serve 2. And my theoretical yield was 4. So if I do the math here, that should come out to be 50%. So my percent yield is 50%. Okay, so does that make sense? So my limiting reagent was my chicken because I was limited as how many snackers I could make based off of how many pieces of chicken I had. My theoretical yield was what I could actually produce. I could produce 4 snackers, but I have some defective ones. So I have to remove those out of the equation. And so my actual yield, what I'm actually going to be able to serve, would be 2 snackers. So I took my actual yield, 2 snackers, divided by my theoretical yield, the amount that I was actually able to produce, 4, divided and then multiplied by 100%, and I have 50%. So my percent yield is 50%. So as we go through now some actual chemistry problems, I think if you use this analogy, it will help you understand those terms better and what they mean. Okay? So let's get ready to do that. So I'm going to move this out of the way. And then I'm going to just erase this and we'll take a look at our first problem. Oh, okay, so here's our first problem. And again, you can pause this. Oh, let me not show you that yet. You can pause this and write this down. But here's what we're going to do on number 1. We're going to take this is what we're given. We're given 48.3 grams of sodium and 72.1 grams of chlorine. And that's going to yield or produce 112 grams of sodium chloride. And so here's what we're going to calculate. We're going to find the limiting reagent, and I've just abbreviated LR because I'm going to need to abbreviate due to board space. The theoretical yield, which I abbreviated TY, and then we're also going to calculate the percent yield. So the Na and the chlorine are kind of like maybe the cracker and the piece of cheese. And then the NaCl would be like a final product being a cracker with a piece of cheese on it. So here's our roadmap. This is how we're going to go about solving this. We're going to go from grams to moles to moles to grams. And then we're going to do this with both the sodium and the chlorine. So along the top, that means that we're going to solve this by going grams of sodium, converting that to moles of sodium, converting that to moles of sodium chloride, converting that to grams of sodium chloride. And the same thing along the bottom, except this time with chlorine. Okay, so again, you can pause that to write it all down and then push play. So our formula, we start with that. Okay, so this is the formula for that problem. Again, it's a synthesis reaction where we have sodium and chlorine yielding or producing one product. And I'm just underlining the coefficients to show that it's balanced. If you aren't sure how to balance or you need some practice on balancing, check out my other YouTube video on using the means method to balance equations. I know that the 1 is doesn't have to be there. It's understood that there's a 1 there, but I just like to put it because you're going to see in just a minute. So with this, I like to do this in 2 steps. So with step 1, I like to let's look at the ratio. So with my ratio, I have 2 sodiums. We'll look at the ratio for sodium, and then we'll look at the ratio for chlorine. So I have 2 sodiums. Actually, let me stick a word in here. I have 2 moles of sodium. This is a ratio. And 2 moles of sodium is equivalent on the ratios with 2 moles of sodium chloride. Okay, so it's a 2, so the ratio of sodium to sodium chloride is a 2 to 2 ratio. We'll do the same now for chlorine. I have 1 mole of chlorine. And the ratio from here to here, it's a 1 to 2 ratio. 1 for chlorine and 2 for sodium chloride. Okay, you can get this ratio just by looking at this, but when I'm teaching this to my students for the first time, I like to just separate this because it will help in just a minute when we do our whole equation. So let me look at what the problem was again. The problem said that we have 48.3 grams of sodium. And I like to work the 2 parts at the same time. So I'm going to put that over 1. And then we have 72.1 grams of chlorine. So that's what we were given. Okay, that's what we were given. It says it yields 112 grams of sodium chloride. Well, we're not at that part yet, okay? So we're just doing the top. We're going to find the limiting reagent and the theoretical yield. So how we do that is, if you remember the roadmap said we're going to go from grams of sodium to moles of sodium. And we're going to go from grams of chlorine to moles of chlorine. So I want to get rid of grams per sodium, so that goes down here on bottom. And I want to get rid of grams of chlorine. And I want moles. I want moles of sodium, and I want moles of chlorine. Okay, in 1 mole, how many grams of sodium are there? So that's where we go back to finding the molar mass. Okay, remember that? We talked about that just a bit ago. So the molar mass, we have 1 sodium. So it would be like sodium, we have a quantity of 1, and we multiply it by sodium's rounded atomic mass, which if you look on a periodic table, it's 23. So 1 times 23 is 23. And then our grams of sodium cancel. Down here with chlorine, so what's my quantity? I have 2. I have 2 chlorine, and chlorine's rounded atomic mass is 35. So I have 2 times 35, and that gives me 70. Now, following our roadmap, we want to go from moles of sodium to moles of sodium chloride. So I want to get rid of moles of sodium, and I want moles of sodium chloride. And down here, I want to get rid of moles of chlorine, and I want moles of sodium chloride. So we just look up here where we did our handy dandy ratios. That's all this is. So I'm looking for the ratio here of moles of sodium to moles of sodium chloride. So my ratio is I have 2 moles of sodium and 2 moles of sodium chloride. And my ratio with chlorine is 1 mole of chlorine and 2 moles of sodium chloride. So my moles cancel. And then I'm on the last part of our roadmap. Now we're going to convert from moles of sodium chloride to grams of sodium chloride. So I want to get rid of moles of sodium chloride. And I want grams of sodium chloride. So in 1 mole of sodium chloride, and I think, let me take a look here. Yes, when we did our review here, we actually found the molar mass of sodium chloride. It was 58. So 58. And then moles cancel, and I'm left with grams of sodium chloride, which is what I want. So I know a lot of times with dimensional analysis or factor label method, you may want to be tempted not to write down the units and then just write down the numbers. But I tell you, doing this, if you write down the units, that will really guide you as to what numbers you plug in. Okay. So if we multiply across the top and divide across the bottom, I've already worked this out. I rounded my answer just to the nearest whole number. I got 122 grams of NaCl. And then down here, when I multiplied across the numerators, divided by 70, oh, you know what? I need to actually do that one. Let me actually do that one along with you. So 72.1 divided by 70 times 2 times 58. I got 119. I'm just rounding to the nearest whole number. So I got 119. Okay, so think of this I just want you to see the analogy here. I know the ratios are different when we were doing our snackers, but just hang with me, okay? So it's kind of like this. Let's say our snacker, though, didn't have chicken on it. Say it was just a cracker and cheese. So let's say that the NA was kind of like our cheese, and the CL is like our cracker, and this is our snacker over here. Maybe I'll call it a snack stir. Snack stir. Since it doesn't have the chicken. Okay, so if you kind of hang with me just to see the analogy, I know the ratios are not the same, but this is kind of like saying, hey, I have 48.3 little blocks of cheese, and with those 48.3 blocks of cheese, I can make 122 snacksters. And over here I have 72.1 crackers, and with those 72.1 crackers, that's enough to make 119 snacksters. Okay, so how many snacksters can we make? That would be the cracker plus the cheese. Well, I can only, of these two, I can only make 119, right? Because then I'll run out of crackers. After 119, I don't have any more crackers. So what am I limited by? I'm limited by the number of crackers. In this case, chlorine. So our limiting reagent is our chlorine, and our theoretical yield, that's the amount that we could actually produce given our ingredients here, and that is 119. All right. So, in order to calculate, so does that make sense? So if we think of this in terms of cheese and crackers, I think it helps out. So again, 48.3 slices of cheese can only make 122 snacksters. 72.1 crackers can only make 119 snacksters. So this is the most I can make because then I'll run out of crackers. So I'm limited by my crackers. Okay, so now if we use the sodium and the chlorine, I can only make a total of 119 grams of sodium chloride because after that I will run out of chlorine. So chlorine I am limited by. My limiting reagent is chlorine. My theoretical yield is 119. It's always going to be the lower of these numbers. And then our percent yield, or let's see, I'm kind of running out of room. Let me actually put it up here. Because our question also asked us to find the percent yield. And percent yield, remember, is actual yield divided by theoretical. Well, this is our theoretical. And in the problem, in our original problem, it says that this yields 112 grams of sodium chloride. So this is what was actually produced. This is what theoretically can be produced. So this is like my little snacksters that were not defective. And this is my total number of snacksters I could produce. So to find the percent yield, I'm going to take my actual, which was the 112 grams, and divide it by my theoretical, which is the 119. And then multiply that by 100%. And let me get my calculator out. So we're going to go 112 divided by 119 times 100 percent is 94.1%. So our three answers are our limiting reagent is chlorine, our theoretical yield is 119 grams of sodium chloride, and our percent yield is 94.1%. So I hope using the analogy with the snacksters was helpful in understanding what these terms mean, and then when you get your answer, what that actually means. And so hopefully you can continue doing those without too much difficulty. As always, have fun with chemistry, and until next time, this is Professor Means.